Why do electrons move from atom to atom? Previously, we explained that electrons go to the shells around nucleus. Every shell would have a capacity for electrons. Recall the last shell as the valence shell, and atoms would want to fill the capacity of their valence shell to be more stable. There is a rule of thumb called the octet rule, which states that elements would like to have 8 electrons in their last shell or valence shell. As an example, Na, the sodium, would fill its last shell by losing 1 electron, and Cl would do the same by gaining 1 electron. So, when put together, electron moves from Na to Cl, making Na more positive since now it has more electrons than protons, and Cl more negative. And since positive and negative attract each other, in this case, actually, we say Na is a positive ion and Cl is a negative ion. And since negative and positive, they attract one another, so they do so. And they make a bond which we call an ionic bond. So in this case, we say Cl very much wants to attract electrons. So we create an abstraction and call this a statement of want to attract electron as electronegativity. So Cl has a high electronegativity and Na has a very low electronegativity. This much difference in electronegativity resulted in ionic bond, or resulted in what we call ionic bond, which means that one gives electron, one gets electron, therefore one would be a positive ion, one a negative ion. They attract one another and therefore they form a crystal. So if the two atoms put near one another instead had a more similar electronegativity, then it wouldn't be like one of them wanting to attract electrons and one to lose, but still they would want to complete their valence shell, right? So they would share their valence electrons, forming a bond that we call the covalent bonds. Obviously, you might guess if one of them still wants electron a bit more than the other, then the electron in the bond might be closer to it, and so we might call it a polar covalent bond.